Hey everybody, we're going to take a look at graph reading. This is something that you practiced yesterday, but let's talk about what is going to be expected out of this class. We're going to be focusing on that identification and interpreting a graph. Now this is of course awesome to be applied to our class, but also for any standardized tests that you may need to take. Even when we're taking a look at the ACT, notice that even in the reading strategy section, you still have to be able to pay attention and to do what you need to do in regards to graphs and tables. Remember, that idea of making generalizations helps when we look at trends, but also just trying to understand what's that main idea. Even though this is related to reading, this idea of main ideas apply to graphs. So we just took a look at how does that graph reading apply to the reading, but we also are going to take a look at this idea in regards to the math. Notice that we have this whole section here that says problem solving and data analysis. And when we look at that, we're seeing about 16 questions on average of what you'd be asked for. So if this is going to be a nice portion of our assessment, especially when there's only 25 questions, we want to make sure that you guys are rocking it and doing your best. When I'm taking a look at data, we have been told over and over that we have a qualitative and a quantitative look to data, either in a graph or a table. When we are taking a look at this class, typically with a focus on chemistry and physics, as PSI is, we are looking at that quantitative data, where we are taking a look at those numbers and how are we getting those either through some measurements or we're recording data that we get, but we are taking a look at these actual numbers and how do they work with each other. There are multiple types of graphs. Now, when I take a look at these choices here, I would say for sure we're definitely going to be taking a look at line graphs this year. This is really taking a look at two variables and how do they interact with each other. Now, of course, this would also come from a data table that you would collect over an experiment. We also know that a scatter plot could also help in regards to its correlation. These circle graphs and these bar graphs are something that you're very used to seeing, and maybe you saw it more when you're taking a look at a biology or an earth science class. But when we're taking a look at these graphs, they're telling a story, and we want to be able to best interpret and identify those main story parts. Since our goal is to look at that quantitative data, we need to make sure we remember our two types of variables. When I take a look at my variables, remember we have my IV, which is my independent variable, and my DV, which is my dependent variable. When I'm looking at a data table, which could very easily translate over here to a line graph, remember the IV is the variable that you would manipulate, and you would place it down here on the x-axis. The dependent variable is what you would record. What would you want to observe? This, in this case, would just be this data that could very easily be translated over here on the y-axis. So let's practice independent and dependent variable using this graph of Atlantic tropical cyclones. When I take a look at the independent variable, I would notice that it's going to be on the x-axis, and I would say that the variable is probably time. Even though it's not labeled as that, my independent variable is time. When I look at how time is recorded, my unit would be decade. Of course, decade would mean years. My dependent variable over here on my y-axis is taking a look at the percentage of these storms during this particular time period from 1951 to 2008. Percent, of course, would be the variable, and I would say that the unit is also percent. Now, this is a task that you're very used to doing, and I'm hoping that we're working on being perfect at it. But what we are adding to this class is making sure that you can look at the trends. This graph is taking a look at 3 different types of storms. Ones that are named, ones that are actually turned into hurricanes, and of those hurricanes, which ones are the major ones that we will kind of always remember. When I take a look at these 3 different scenarios, I want to know, how do they work together? What's their correlation? Are there similarities? Are there differences? And that's the goal of our I2 strategy. The first part of doing this strategy is taking a look at identifying. What do I see? Well, we're going to start with the easy parts. You should be always to tell, what do you see? Well, I see time down here as my independent variable, and I see that the unit is going to be in months. I also take a look at my dependent variable, which is always going to be over here on my y-axis, and I see that the unit, I see that the title of this, or my variable, is temperature, and I am using the degrees Celsius. Tasks that we know how to do, but it's the identifying that we're asking you to get more detailed. Notice what they commented on. They noticed that there was an upward slope, they noticed that there was a peak, and they noticed that there was a downward. When you just be able to pick apart, oh, this is going to tell us so many stories. Typically in standardized testing, they always want to know what was the highest or the lowest. So you can even identify those parts as what was high and what was low. Always good things to identify. But notice, why would it increase and why would it decrease? Well, that's becoming part of the analysis. That analysis, we're going to call the interpretation part. What does it mean? Well, we come to, what did we see? And we saw an upward slope. But now we're going to take a look at, and what does it mean? Why from February to July? Why would that temperature increase? Well, silly, you know that it's probably turning spring into summer. Then if you have a peak because what you see, well, what does that mean? That means it is the hottest point of this year in one U.S. city. Going back again, what did you see in that previous one? We saw a downward slope from July to December. But what does that mean? Well, of course it means that we're moving into fall and winter. Do you find it kind of neat that when I take a look at my lowest points of December and January, that we're pretty close in temperature? Well, that would make sense. We're both kind of in the dead of winter. Putting it all together and practicing kind of a writing and summarization skill is the caption. Notice how it's going to start. We have a very first sentence talking about, this graph shows the average temperature of a city over a year. Where did you think they got that information? Remember, when I'm taking a look at the title of any graph or data table or bar graph, that I'm look at it and I'm like, that's the information that's going to help me. The very title is the very first sentence. Then we kind of pick apart what's happening. We talk about, what did you see? You saw that upward slope. You saw the downward slope. And you saw the peak. How that flowed from that very first step of identifying is how you summarize it in the caption. The best way to practice our new strategy is to take a look at an example. When we take a look at this type of graph and the graphs that follow, we're going to take a look at the basics of the graph. By noticing the data points and the lines, we have a line graph. The title of the graph is typically at the top. My independent variable will be on the x-axis. Since this is talking about fantasy sports in regard to age, age is going to be my variable, whereas years will be my unit. My dependent variables on the y-axis. Since I'm taking a look at people who responded to a survey, my variable is that percentage of people responding, which of course would be in percentage. Here's another graph. This time it's representing a bar graph of the number of Starbucks stores worldwide from 2003 to 2018. We can take a look real quick at this, and we would notice, well, I started low, a number of stores, and then in the thousands, and of course I am much higher up here at the top. I would say that if I drew a line kind of connecting the tops of all these graphs, that I can go ahead and make a line graph. That's the cool thing about a bar graph, that it can translate into a line graph. It's the exact same information that was just shared in the bar graph, removing the bars and keeping that top point. Now I have all the data points. Now it's easy to read for sure because it's a line graph. Can you take a look at all the basics of the graph? Can you identify what type of graph it is? Do you notice the title of the graph? Can you identify the independent variable and its unit? And can you take a look at the dependent variable as well as its unit? In the previous slides, we've taken a look and practiced the basics of the graph. And of course, that is identifying, which is part of our I2 strategy. But the other part about identifying is what do you see in the graph, is really taking a look at how did the data change over time or over the course of the graph that it represents. Easy things to take a look at are lows and highs, maybe a spike and then a drop. This helps us identify the trends. Notice the rubric that I have up here is that you will earn points by identifying all the trends that are possible. We also could say that there is that increase here, and then it also continues to increase. And of course, there is that decrease there. All this helps us to figure out what does it mean. You've already labeled what you've seen, so what would that story behind? We could say in general, in the course of 17 years, that the daily rate of hotels in the United States has increased. I can also say that it was continuing that trend until 2008, when there seems to be a drop-off. And I would say, well, that would make sense. Even though you may know that this is the time that we were having a recession, it would make sense that the daily rate of hotels would drop. Sticking with this idea of hotels and looking at the number of users in a hotel, let's take a look between 2017 and 2023. Even though this is in the future, it's still a prediction based off of a trend. So what do I see? Well, we can say that we started here. We have a peak, we have a drop, and we have kind of a prediction of what would happen. that prediction would be that the usage over the next 3 years will increase. We can also see that there was a major drop. Well, I'm hoping that looking at this, you can take a look at what does this mean. And I think everybody knows that this drop from the end of 2019 to where we're currently at in 2020, well, what does that mean? It means COVID. The good news is that this is making a prediction that after this is happening, after we have a vaccine, we're going to be going right back to the way things were. And the coronavirus and COVID-19 are what we're going to see in the remaining slides that we're going to practice our identification and interpretation strategy on. The first one is to take a look at, well, there is no title for this. So we are looking at it as a bar graph, but what would be a good title for this? Well, remember, what shows up are always your good options for a title. So this would be maybe the total cases versus the total amount of deaths in the United States as of mid-July. Notice that the details, even though it is not a title, but I could go ahead and use it. I would take a look at that in this bar graph, and in comparison, my total number up here, I'm in the millions. This graph does have its title, and its title is saying the change in dollar sales as of March of 2020 by categories. So when I take a look at what do I see, of course I see my highest percentage in change, and I see my lowest change percentage. And I can of course relate it to paper products and cosmetics. With this high and this low, I can interpret, what does this mean? Well, we all know that in March 2020, during shelter in place, there was an outbreak of where's the toilet paper? Well, why is that? Well, there was a 59% change in the sales of toilet paper. Now, if I take a look at the lowest, why was there only a 3% change in the sales of cosmetics? Well, they all go together. We were all in shelter in place during March of 2020. We wanted to make sure we had enough toilet paper, and we wanted to make sure that we were hanging out at home and we weren't really getting ourselves all ready. Another interesting way of taking a look at the coronavirus and its effect on different industries is taking a look at an opportunity here to look at positive changes and of course negative changes. So when I take a look at this particular graph, we can see that once again that change in grocery stores was the biggest change, whereas as we already talked about with the hotel rates and the hotel usage, that tourism was going to have the most negative. Once again, what did I see? I saw the most and I saw the least change. And I could go ahead and take a look at the least amount of change as well. And we're taking a look at here and here. Of course, those are more negative change, but these are the smallest changes. That would make sense when we're taking a look at that traffic kind of from the start of Corona to mid-June. Following up with one more bar graph, let's take a look how those grocery or that supermarket positive change was and what specifically people were buying. We're going to use this bar graph to help us with our interpretation. Why were these items picked? Well, interpret that. Why do I have pasta, evaporated milk, a lot of canned items that are available, and of course, broth to make soups? Why were these on a change in grocery orders? Well, people were nervous about buying. People didn't know when they would Go back to the stores. People didn't know how long stores would be open if everyone was buying. So these items are items that can stay in your pantry for a while, and they can be used in a whole bunch of stuff. A bar graph sets it up pretty easily that we have our highest and we have our lowest. But let's talk about that highest. Remember, what you're looking at as the dependent variable is the percent change in growth. And all these are positive. But why is pasta at the top? Pasta's cheap. So that would have that biggest increase as well as longer shelf life. Ladies and gentlemen, here it is, our last graph to walk and talk through. Before I provide answers, I'd like for you to do all the parts that were reviewed during this PowerPoint. Using the graph that you see, be able to identify the basics of the graph. Think about questions regarding the graph. Using those questions to say, what do you see? And start thinking about what does it mean, which lead us to your interpretation. Try it out and then check out the answers on the next slide. Let's see how well you did. You were looking at a line graph. The title is looking at the different continents, the different areas of our world, and their daily reported COVID-19 cases. Those cases are going to be your dependent variable, and those are in the thousands, whereas your independent variable is the time, and it's showing a 3-month span. As we already said, we're talking about the different areas and their COVID numbers. Hopefully you noticed that there were upward trends for Europe and the Americas with a spike in mid-March. You saw that the Mediterranean, the Asian, the African, the Pacific also have an increase, but they have a much more gradual and much lower. Hopefully you also noticed about April 15th that Europe turned downward while the Americas kept moving upward. But there was an interesting spike around May 10th. You could probably make a prediction that the Americas will continue to rise, Europe continue to decline, and the others would possibly flatten out. And your inference or your interpretation is that each section of the world have different politics associating their handling of COVID-19 cases.